Okay, let's just dive right in. For years, we've seen these different pieces of the AI puzzle kind of clicking into place one by one.
Right.
We had large language models, LLMs, that basically solved generalized intelligence. Then you have text-to-speech, TTS, which absolutely nailed the human voice.
To the point where it's, almost indistinguishable.
Exactly. And computer graphics. I mean, they solved the photorealistic static face a long time ago. Think back to that 2015 digital recreation of President Obama. It was uncanny.
It was incredible. So all the pieces are there.
All the pieces seem to be there, but there's always been this this final bottleneck, the thing that holds it all back,
Yeah.
making that digital person move naturally.
Yes.
The motion. We're not talking about just talking heads.
No.
We mean gesturing, expressing emotion, having real body language that syncs up perfectly with what's being said.
Without it feeling robotic or, creepy.
Which brings us to today's deep dive. We're looking at OpenHuman.ai, a platform that claims it's not only solved this motion problem, but that it's building the entire operating system for this new reality.
The app store of digital humans, as they call it.
And what's really compelling here, for you listening, is that we're not just going off marketing materials.
No, not at all. Our sources are really detailed. We have system architecture diagrams, research proposals, even their business strategy docs.
So we can see the how.
We can see exactly how they plan to solve not just the motion problem, but also the big distribution and integration gaps that have, frankly, paralyzed this whole field for a decade.
So let's start there. We've got the brain with LLMs, the voice with TTS, the perfect look. Why hasn't this digital human revolution already happened? Why are we still mostly typing into chatbots?
Because the hardest part isn't generating an image or some words. It's generating all that subtle, nonverbal communication in real time.
The stuff we do without thinking.
Exactly. If the avatar's hands just sort of flop around, or its smile is a fraction of a second too late, the whole illusion just shatters.
It goes from conversational to creepy in a heartbeat.
And it's not just about random movement either, right? It has to mean something. This is where the technical challenges really stack up.
Okay, like what specifically?
Well, first there's what they call semantic gesture synthesis.
Okay.
So if the text is, I have 3 points to make, the digital human has to actually raise 3 fingers.
It can't just shrug. It has to understand the semantics of the language and translate it into a physical gesture.
Precisely. Then second, the animation has to be completely emotion-driven. If the AI is talking about something sad, the face, the posture, everything has to reflect that melancholy state.
And it has to happen instantly.
Instantly. The target latency is incredibly low, under 100 milliseconds. Any more than that, it just feels laggy and unnatural.
Which is why we've been stuck with these closed proprietary systems. They're expensive, they're not portable.
Right. And OpenHuman's whole pitch is that they are solving that scalability and distribution problem. They're building an ecosystem for creators, a platform, and then for end users like you.
Okay, so this brings us to the core breakthrough, the secret sauce. How is OpenHuman making these gestures feel real when so many others have failed?
Their motion AI is, it's really built on some bleeding-edge academic research. They're drawing inspiration from models like dephase and diffusion models.
So not the old school rule-based animation you'd see in like a video game.
Exactly. They're moving away from that stiff procedural look. This is a generative process. The engine takes in everything, the text, the audio, the emotion, even the conversation history, and generates movement keyframes at 60 frames per second.
And using a diffusion model, that's what gives it that natural variation. It avoids the repetition.
That's a key. It fills in all the subtle noise of human movement. It ensures what they call temporal consistency, so the gestures flow smoothly. They don't just jump from one pose to another.
And this is trained on huge data sets of actual human movement.
Massive data sets. Things like the beat data set, which has over 76 hours of detailed, synchronized gesture and speech. The AI has this enormous vocabulary of motion to pull from.
So the body moves naturally. What about the face? For an App Store model to work, every face from every creator has to work flawlessly on the platform. How do they standardize that?
Yeah, standards are everything here. For facial expressions, they've anchored on the industry standard, which is ARC-IT blend shapes.
So the same tech that powers animojis on an iPhone?
Pretty much. Every face is built around the same 52 to 60 parameters. It creates a kind of universal emotional backbone. A smile on one character translates perfectly to any other.
And they provide base models to make it easier for creators to get started?
Yes. They're not asking everyone to start from scratch. They reference benchmarks like the 3D Scan Store base mesh. That standardization is what allows the motion AI's output to look good on, any character rendered in any engine.
Let's get into the infrastructure, because the concept of running thousands, maybe millions, of these super realistic digital humans at the same time, that sounds like a computational nightmare.
It would be, but their architecture is really elegant. They call it an artificial neural ecosystem.
What does that mean?
It means each component, the vision part, the audio, the expression generator, is its own tiny independent process, a little neuron.
And they all just communicate with messages.
Right. But the question is, how do you keep that stable at scale?
Yeah, what if one of those neurons just dies?
That's where they made a very smart choice. The whole backend is built on Erlang, OTP, and Elixir.
Which is famous for fault tolerance. Telecom-grade stuff.
Exactly. It's designed for systems that cannot go down. So if one digital human's process crashes, it doesn't affect anyone else. Each human is its own supervised tree, completely isolated and crash-resistant.
Okay, so that handles stability.
Yep.
But what about customization? If it's an app store, creators need to inject their own unique logic, their own behaviors. How do they do that without creating a security mess?
That is a great question. And the answer is WASM, or WebAssembly.
So they let creators upload their own code.
In a way. They upload these WASM modules. Think of it like a safe sandbox little function that defines the human's unique logic, their soul, if you will.
And because it's sandboxed, it can't break the main platform.
Precisely. It's secure, it's portable, and it can run anywhere, from a powerful desktop to a simple kiosk display without any changes. It's a really clever solution to a complex problem.
So we have natural movement, we have a stable infrastructure, and we have secure custom logic. But the thing that really changes the game, according to these documents, is context synchronization.
Absolutely. This is the killer feature.
The idea that the digital human follows you from device to device.
And it remembers everything. It solves that persistence gap that makes current assistants feel so stupid. We hate having to repeat ourselves.
So how does that memory system actually work?
It's a tiered system. They have short-term context, which is like the verbatim transcript and the emotional vibe of the last hour or so.
Okay.
And then there's long-term memory. That's where it stores your profile, your relationships, your preferences, key facts you told it months ago.
And this syncs across all your devices in under 100 milliseconds.
That's the target. So the assistant is always up to date, whether you're talking to it on your phone, your car's dashboard, or a smart mirror at home.
Let's walk through that scenario. Let's call the digital human Emma. This is really the aha moment.
Okay, so you wake up, you go into your bathroom, and your smart mirror turns on. Emma appears.
Instantly.
Instantly. She greets you, reminds you about your 9 a.m. meeting, and maybe even notes you seem a bit tired based on your expression.
And you get in your car.
The car's display boots up, and there she is again. Emma seamlessly transitions. She's giving you traffic updates, and because she remembers you are prepping for a big negotiation.
She suggests a podcast on the topic.
Exactly. Negotiation edge. The continuity is total. She didn't just move, she moved with context.
Okay, so you get to the office, you sit down at your desktop.
You open the app, and Emma appears again. But now she's in, say, business attire. Her appearance and tone have adapted.
That's a critical detail.
It is. And you start going over some budget slides, and she interjects. She says something like, that 22% growth projection seems optimistic, because she remembers a conversation from a month ago where you were worried about a competitor.
That's proactive. That's long-term memory retrieval. It's not just an assistant anymore, it's a collaborator.
It really is. And then one last step. You're at the supermarket on the way home.
Okay.
You scan a QR code on a public kiosk, and Emma appears on that big screen. She immediately says, don't forget the milk, and suggests pasta for dinner based on your known preferences.
This whole sequence, it demonstrates three huge things. The continuous context, the adaptive behavior, and just zero friction. She's just there.
A truly unified companion. And that's only possible because of the creator economy they built around it.
Right. How does someone actually build an Emma?
It's three components. First, the personality, the brain. That's just an LLM API endpoint.
So you can plug in whatever model you want.
Whatever you want. Second is the appearance, the body. You bring your 3D assets. And third is the behavior, the soul. That's the custom emotional mapping in those WASMs and modules we talked about.
And the business model for the creators.
It's a 70-30 revenue split. The creator keeps 70%, which is quite generous. The platform takes 30% to cover all that real-time infrastructure and payment processing.
With flexible pricing for the user, subscriptions, one-time purchases.
Exactly. So the applications here are they're massive. Personal assistance, customer service, education, healthcare. It could change everything.
So what's the long-term vision? Where does this go in 5 or 10 years?
Well, the documents talk about ubiquitous digital humans. The idea that nearly everyone will have at least one digital companion helping them manage their life.
And it goes beyond that. Metaverse integration, persistent identities.
And even AI to AI communication. Your digital human negotiating with someone else's digital human to schedule a meeting, for example, without you ever being involved.
So, to synthesize all this for everyone listening, OpenHuman isn't just making a better avatar. They're building the entire foundational layer, the OS, the marketplace, for this whole new category of embodied AI.
They're solving the two biggest hurdles at the same time. Natural, real-time animation, and seamless distribution to every device you own.
And their market projections are ambitious. They're forecasting capturing, what, $2 to $5 billion of the digital assistant market by 2030?
They are. It suggests the future of how we interact with technology isn't just conversational. It's profoundly visual, it's personal, and it's all built on that layer of continuous, persistent memory.
Which leaves us with a really important question for you to think about.
Yeah, if your digital companion follows you from your car to your mirror, and it never ever forgets a single detail or emotion, what new boundaries do we need to set for privacy, for emotional reliance? When an AI becomes that ubiquitous, that personal,